Hi everyone. This is another question from 2022 AMC 10A. So this is the number 17. So actually, it's not a good question. I really enjoy doing it. So here's the problem. So we have a repeating three digits after decimal point right here, and then ABC is repeating, and that is given actually 1/3 of the repeating digit of those each separate as a single digit after the decimal point, okay? And the question is asking how many positive integer A, B, and C are actually gonna satisfy this equation. Okay, so like if you are not familiar with the repeating this like decimals, maybe this might be a bit challenging, but as a quick review, so let's say you have a like number that is a one single digit repeating, so that is actually equal to 4/9, okay? And then if you are wondering why this is the case, like we use actually something like this. Let's say I'm gonna call this guy as 0.4, and then that 4 will be repeating, right, forever. And then if you want to find the value of this guy as a fraction, so we are actually going to use a maybe approach to like get rid of those repeating pairs. To do so, we are just going to multiply this guy by the some like multiple of tens. Like if you have one digit as repeating, then you do multiply this by just 1/10. If you have two digits repeating, you just multiply by 2/10 and stuff like that. So, and then you will see why we're actually doing that. So if I do this, let's say if I multiply this by 10, so when you multiply this by 10, you move decimal point to the right by 1 unit. So your number will be 4.4. And then these fours will repeat infinity, right? So that will be the same fours just going forever. And now the reason that we actually multiply by 10, so we can actually cancel those repeating pairs when we actually find the difference. So if I do multiply the first equation by -1, okay, and then that will give me 9x minus 1x, which is just 9x. And then like 4 minus 4, 4 minus 4, 4 minus 4, all those fours will cancel each other. That will just 0. And then 4 minus 0 just 4. So that will be 4.000 like forever, which is the same as 4. And if you divide by 9, so you get x as 4/9. Again, if you do have just one digit, so that's what you have. If you have maybe more than one digit, let's say we have 0.47, then you can just for the like 7/99. So if you are wondering why this is 99, like when we got this 9, when we multiply by 10, the difference was actually 9. But when you have two digits, it's repeating. Okay, actually this is repeating. Then you're gonna need to multiply this number 0.49 by 100, so you can actually line like those 49s, like so we can cancel those when we subtract. So we just multiply this number by 100, so you get 100 minus 1x, which is going to be 99x, is equal to 47. So that will be just this guy. Anyway, this is just the background. So if you are not familiar with that, that's probably something you want to review at some point as well. Okay, but anyway, so for this problem, I can say this guy ABC. Again, there are some other approaches. Let's say if you have a digit in between repeating with repeating digit and the decimal point, if there is something that is not really repeating, let's say 47.1, let's say only 71 is repeating, then you are not going to be able to say 471/999 or 471/99. So you cannot say that. That will be something different, but the approach will be the same. So you can explore that as well if you like to. Anyway, so for this question, I have 3-digit repeating, so I can write it as ABC as 3-digit number divided by 999, and is equal to, okay, so A, I can write actually 1/3, and this guy will be A/9, and that will be B/9. So we have C/9. So it doesn't really look fun when you deal with fraction, when maybe we can multiply this 1/3, and that will be like A/27 and stuff like that. But there's a 999. Maybe we can multiply everything by 999. So that will be ABC, which is like, keep this in mind, it's another multiplication. This is 3-digit number. of ABC. And if you multiply by 999, so you get cancel those. So that will be 999 divided by 27. Actually, that will be 37. So 37 A plus B plus C. Okay, so now like this guy, 3-digit number, but these are just the sum of those digits, so it's not as like 3-digit number. So I just need to expand this guy. This guy can be written as 100A plus 10B and plus C, right? And that should be 37A and 37B and 37C. So again, this is just the expansion of this 3-digit number. Just assume like 1, 2, 3. So that will be 100, 2, 10, and 1, 3. So instead of like 1, 2, 3, we have A, B, C. So that will be 100A, depends on this digit, and then 10 times this second digit, which is 10 times B, and you can expand this way. So now, if you subtract 37 from 100, so it should give you 63A. And that will be subtract 10B from both sides, 27B and 36C. And I think everything divisible by 9, so that should be 7A is equal to 3B plus 4C. Okay, so now we have this one. This is a bit better than what we start with, but still, this is the only equation that we have, nothing other than this, right? So, but we need to remember A, B, C are digit, so they has to be positive integers. So that means even though we have just one equation with 3 unknowns, we can actually find those values. And then choices are not too many, so we can go ahead and maybe go with count those like carefully. So since maybe 7 is a larger like coefficient of those 3, I can maybe start with some case, starting with A, right? If A is 1, okay, then you will get 7 equals 3B plus 4C. Only way that will be equal to 7 if B is 1, C is 1, right? So that means you get 1, 1, 1. So that's one pair. So if you got unplug it, you'll probably see that's the case. That's the one thing, one pair actually, 1 triples, right? Okay, so we can just get 1, 1, 1. It's one 3-digit number. So if my A is 2, then that'll be 14, right? So let's say 14 is 3B plus 4C. At this point, you can just use your like logic to see what number should I pick for B and C to get 14. Base R has to be like these A, B, like B and C has to be positive numbers. So you can maybe start with C's. So if this is like 1, that will be 4. But at the same time, when you subtract, you get 10, that's not divisible by this. So I should probably go with this is 2, which is 8. And to get 14, that should be 2 as well. So then if that's the case, you actually 2, 2, 2, which is another pair, and then there is nothing else. And if I do with A equals 3, okay, and then that should be 21, okay, and then 3B plus 4C. At this point, I'm gonna stop a bit, because if you just keep doing this, this is okay. You can finally find all the pairs. Like it looks like when you choose 1, we have 1. When you choose 2, we have 1. Maybe when you choose 3, we will have 1. It looks like you might have 9, but in some case you might have more than that. Okay, we just need to be careful. So at the same time, you know, the sum of those two, 3B and 4C, is gonna give a constant number. So if you like make this number a bit smaller and this number a bit larger, maybe we can get a couple different ways to get the same sum. But in the first two cases, we just had only one 3 integer pairs, like 3 integer triples. But now maybe you can get something like that. But anyway, so if this is the case, like this has to be, C has to be multiple of 3, because this is gonna be multiple of 3, and the sum is multiple of 3, so there has to be, C has to be multiple of 3 as well. So then I can go with 1, which is not gonna work, because if you subtract 4 from that, so you will get 17, which is not divisible by 3. If I go with 3, that's 12, and then there will be 9. So 3 and 3 does actually work. So my next 3 integers will be this pair, this triple as well. So again, I cannot make this guy like smaller, like if I make this guy 4 smaller and this guy maybe 4 larger, maybe, I mean, yeah, actually I can do that. So maybe I can get similar like result, but if I make this 4 smaller, I will not get a positive, so we cannot probably try that anyway. So, but in some cases we can try. So if you don't get what I'm trying to talk at this point, so you will see in next, I guess, cases. If this is 4, so then you get 28 is 3b plus 4c. At this point, you may probably want to use mod if you like to make it a bit maybe less complicated for the unknowns. Anyway, at this I can choose, like you say 1 1 2 2 3 3, maybe 4 4 4 will work. If I choose like 4s, that's really 16, that will be 12, which is 28. Yeah, that actually works. Okay, but this is what I'm trying to say. Now we have 4, right? And if I maybe make this guy as 3 lesser, and this maybe 3, maybe 4 larger, so maybe we'll get something else as well. So let's see, like if this is 3 times 7, which is 21, and then 4 times 1, which is like 4, it doesn't look like we are gonna get this one up, right? But actually, yeah, we can try maybe, like if I increase this, like this 4 by 4, because whenever you increase c by 1, this number will increase by 4. So if you increase c by 4, that will be 3 times 4, which is 12. You are increasing this product by 12. So in order for us to keep the same 28, so for C should be increased by 12, which means C has to be decreased by 3. So what I'm saying that, like if I have A is 4, maybe I can increase this by 4, which is gonna be 8. At the same time, my C has to decrease by 3, which is gonna be 1. But let's actually double check. So if I do 4, that's 12, right? And then 4, actually, yeah, B is actually 28. Actually, yeah, B is 8. That's 24. And of course, times C is just 1, which is 28. Yeah, that looks good. So I hope that makes sense. So what I just did basically, after we know this guy, I tried to decrease this B by this coefficient, which is 4. And then I need to increase this C by this coefficient so I can maybe get the same sum, which is actually going to work out. And then I cannot do anything more than that. So I cannot like decrease like B like by 4, because that's not going to be integer, I mean positive integer. So then that's only 2. And then if I have A equals 5, so that should be like 7 5 35, and that is 3B plus 4C. Again, we've seen all these like the equal numbers, 1 1 1 2 2 3 3 3, and it works. So let's try 5 5 5. Okay, and then if you see that that's like that was 5 already, so that was 15, that's 20, that's 35, will work out. So if I increase B by 4, I will get 9. So I should get 5 9, and then I should decrease C by 3, which looks like 2. And you can double check that, but that's not the only thing. We can actually decrease this number and then increase this number. So I can get like this guy, I can maybe decrease by 4, right? Because the coefficient of C is 4, so I should decrease by that coefficient, which is going to be 1. And if I increase this guy by 3, so I should get 8. And then you can always double check. And then I cannot go other than these 3, because if I just increase another 4 or 3, so I will not get a integer. So I have these with 5. And if I have A as 6, again, I'm not going to go through those steps. So I will get 6 6 6. That will work. And then if I decrease this by, okay, if I decrease by like this guy by 4, so that should be 2. And then my C has to be increased by 3, which is going to be 9. And you can double check. And now I can increase this by 4. I cannot do that, right? because if I do this, I'll get 10, which is not integer. I mean, what's not digit. So if I do this 7, so that will be 7, 7, 7. And you can confirm that. And if I do this as 8, that should be 8, 8, 8. And then if I have as 9, so that should be 9, 9, 9. Okay, but now, like, if I decrease this by 4, so I should get 9, 5, but I cannot increase this by 3, so I cannot try at all. So let me ignore this one. After maybe like 6, we don't really need to try at all, because if you do have 7, you cannot increase by 3 or you cannot increase by 4, since one of those should be increased at least by 3. So there is nothing you can have more than one like triples that will satisfy. But let's double check with this one. Okay, so we have like 6, right? So we have 6, 2, 3, 9. And I did decrease this number by 4. If I decrease by 3, so I will get 6, 3. And then if I increase by 4, that will be 10. But that doesn't work. So I don't really need to deal with that either. Okay, so I think these are all. So actually I was gonna erase that part. So if I do this, okay, so then my answer should be actually the sum of these. Actually we have 9 of those already. So we have 1, 2, 3, 4 additional. So 9 plus 4 has to be 13. And yeah, that was it for this problem. So I hope that makes sense.